Okay, so today I will show you how to create the simplest possible game for the Arduino compatible chip, being the ATtiny85. And that's this small chip on the breadboard. So if I press the button, I started the game and I see two dices with different number of dots with different values, and my goal is to press the button when those numbers are the same. And in that case, I became a winner. So if I press the button again and I start the game again, and I press the button when those numbers are not the same, I am not a winner. Again, it's the simplest possible game, but we have to start somewhere in order to create more intricate games. So I have the version of the game running on the breadboard, again using the ATtiny chip, the OLED display and one button, one resistor and few wires. I have also the same game running on this device, which is called TinyCate. You can see that here I have 3 buttons, one buzzer and LED, but I'm still using only one button to play the game. And I've already covered the TinyCate in my previous video. You should definitely watch it if you haven't seen it already, because it has all the important details. And it also has the link to the walkway simulation. Now before we jump to walkway, let me talk about the sponsor of today's video, which is PCBWay. If you need a PCB for your project and you use the link down in the description of this video, you can get 10 PCBs for free, only paying for shipping, which I think is a great price. But even if you don't need PCBs, you can still get a lot of different services from PCBWay, including 3D printing, CNC machining and other types of manufacturing. So thank you PCBWay, and let's get back to our video and let's get back to the walkway emulator. Now Walkway is a free online Arduino emulator that supports the ATtiny85 chip, as well as the push buttons, this OLED display, the buzzer and all the other components. And if I run the simulation, you can see that we are already drawing something on the display. Now this display is SSD 1306 128 by 64 pixel resolution, connected using the I2C connection, and for drawing the stuff on the display, we are using the U8x8 library. Now the U8x8 library is a very simplified version of the U8G2 library, and it has quite a lot of restrictions in order to run it on this small ATtiny85 chip. The biggest one is mentioned in the name. The 8x8 means that we are dividing the display into 8x8 pixel blocks, and that's the smallest area that we can update or change. So I think that before writing any code, we should design the content of the screen with this restriction in mind. And for that we will be using a tool called Photopea, which is a free online graphic editor similar to Photoshop. I will create a new file in the size of our display, which is 128 by 64 pixels, with the black background, and hit the create button. Now I want to visualize the 8x8 blocks, and I can do it in few different ways. One of them is to add guides, and there is this guide guy plugin, which we can use to add multiple guides. Again, the screen width is 128, so if we want to divide it into 8 pixel blocks, we need to add 16 guides for the width and 8 guides for the height, and click the Add Guides button. Now this bright blue or the cyan color is kind of distracting, so I can go to Edit, Preferences, and maybe change it to some darker gray instead. And I think that this one looks much better. So again, at any time we can only update one entire block on the screen, being 8x8 pixels, so we should design the content of our game in the way that we use as few tiles as possible. For that I will create a new layer, and then select the pencil tool, which is hidden behind the brush tool, make sure the size is only 1 pixel, and set the foreground color to be white. Now in the beginning I was thinking about creating the dice in a way that it only takes 1 tile, but I realized that this is very small and it might be hard to see the dice on the display. Instead, I've decided to show the content of the cube over 3x3 tiles. So this will be number 1, this will be number 2, number 3, number 4, and so on and so on. So in the end, for the content of the dice, I only need 2 tiles, one for the filled section and one for the unfilled section. I will also need few tiles for the outline, so let's start drawing. I can select the ellipse selection tool, make sure it's not anti-aliased, and then select the ellipse, and then fill it with the white color, but you can see that this doesn't look like an ellipse at all. So instead of drawing it like this, I can just use the pencil tool and draw something that looks like an ellipse instead. Maybe something like this, and then I will create a copy of the layer by dragging it with the Alt key being pressed, and let's for example form the number 5. Finally, let's add a new layer and create the outline, and I can click with the pencil tool, then hold the shift key on my keyboard and click again, and that will create me a straight line between those 2 points, and I can continue like this with all the other sides until I have the outline created. And so just like this, I have a final version of our dice. Now let's count the number of tiles that we need to export. We need 1 tile for the filled section, and we need a second tile for the empty section. Then we need one tile for every side of the outline. So that will be first tile for the top border, one more for the right border, tile number 5 for the bottom border, and finally the tile number 6 for the left border. Since we are simulating the rounded corners by not having these pixels filled, those corner tiles are actually empty and we don't need to store any content. So let's export those individual tiles. I will select the rectangular selection tool and change the size to be fixed size, being 8 by 8 pixels. Then select the fill section, press the Ctrl-Shift-C, that will copy everything into clipboard, and that's this one which is called copy merged, and then Ctrl-V to paste it. And you don't see any difference, but if I created the helper layer, being the color fill of any color, you can see that this is the image that we want to export. And to tell the photopea that we want to export this, we have to name it with the -e- prefix, and let's call this tile dice dot, and continue like this with the other tiles. So this will be empty. Let's call this -e- tile dice empty. Here is the outline top, the outline right, outline bottom, and finally the outline left. And again, if I show the helper layer, you can see that those are the 6 tiles that will be exported. So I'll jump to File, Export Layers, make sure that the format is set to PNG, and click the Export Layers button. And this is the content of the exported zip file. What we want to do is to convert those images into C arrays. And for that, we will be using the image to CPP website. So I'll select all those images, then scroll down and make sure that the draw mode is set to vertical, generate code and copy the output. And we can paste the output into our sketch. There's actually this helper array that we don't need, so I'll delete this one. And we are left with 6 different arrays. Let's try to draw one of those on the display. So inside the loop, I will comment out everything and only keep the draw tile function. Now the position doesn't matter at this point, but we have only one tile, and the name is, for example, the EPB bitmap tile dice dot, so I'll just paste it in here and restart the simulation. And you can see that we have something on the display, but it looks kind of wrong. And that's because in the U8G2 library, the images are stored in the program memory, but that's not the case for this U8x8. So what we have to do is to delete the program as well as the constant. So now those images are stored in the RAM, which is by the way very small. It has only 512 bytes, so we have to be very aware of how many images we have in our sketch. And once I delete everything and restart the simulation, now I see our dot being drawn properly. But maybe instead of drawing the dot, let's start with drawing the outline. And back in the photopea, let's visualize where those dices should be placed on the canvas. And I think that I will move the dot like so, and then move it with the Alt key being pressed and visualize the second dot. You can see that we cannot center those dices on the Y direction, but maybe we will put some text up here, and that will make the layout look better. So as a first tile, we want to draw the top tile, where the X position will be 0, 1, 2, 3. And the Y position will be 0, 1, 2. So we will draw the top tile on the position 3 and 2. And we actually need 2 more tiles being the same, but the X position will be 4 and 5. And if I restart the simulation, I should see the top outline of our dice. And since this seems to be the case, we can continue like this with all the other sides. That should cover the left dice, and for the right dice, let's just copy and paste everything and increase the X position by 7. Like that. And we actually don't need to draw those outlines all the time because they will not be changing, they will be there all the time. And for that reason I can just copy and paste this into the setup function, so it will be only drawn once in the beginning, and then inside the loop function we can draw those individual contents, those individual dots for those dices. So let's actually try that. I will create a new function for drawing the dice, and let's just call this draw dice. And since this function will not return anything, I will start with the word void, and I want to draw the dice on some X and Y position. So for the parameters of the function, I want to know the X offset, the Y offset, and of course I want to know the dice value. Let's call this dice number. Now inside this function, I want to update all those 9 individual tiles. So I will add the for loop. So for byte I equals 0, while the I is smaller than 9, I want to increase the I by 1. And then I want to draw the tile, so I'll just copy this draw tile function. And for now, use the dice.image. The X position will be X offset and the Y position will be Y offset, but that will just draw 9 images on the same position. So we want to change the X and Y values based on the value of I, which goes between 0 and 9. And we want to fill this 3 by 3 grid. So inside our code, we have the variable I, which goes from 0 up to 8. And we want to have some x and y positions. So the x should be 0, 1, 2, and then again 0, 1, 2, and finally 0, 1, 2. And the y should be 0, 0, 0 for the first three, then 1, 1, 1, and 2, 2, and 2. So let's see how we can calculate those values based on this value. So for the y, this looks like a simple division. So I can say that the I value divided by 3 will give me some number. And in Excel, it will give me some floating point value. So what I can do is I want to convert this to integer, which I don't have to do in the C code. But just in order to visualize this, if I do so, I will get the same values. And for the x, I think that we can use the modulo function. So I can set the modulo of the variable I with the number divisor being 3 will give me values 0, 1, 2, and that it will repeat itself. So 0, 1, 2, 0, 1, 2, and 0, 1, 2, which is matching those numbers. So let's just use those equations inside our code. So the x position will be x offset plus I modulo 3. And just in case, let's put those inside the brackets. And the y position will be y offset plus I divided by 3. And since the I is byte and the 3 is also byte, we don't have to do any rounding. It will also end up as a byte variable, meaning there will be no decimal values. So let's try to use this function inside our loop function. So I'll say draw dice, and the left dice should be drawn on the position 3 and 3. And let's just not worry about the value for now because we are not using it. And let's restart the simulation. And as you can see, after we draw the outline, all those 9 positions are being filled with dots. Obviously, this is not possible for our dice, which only have 6 sides. So we need to store those zeros and ones, those empty and filled pieces in some kind of array. And then fill the correct spots, the correct tiles based on the dice value. So let's create a new array of bytes and let's call this dice tile lookup, and that will be to the array because we want to store those 9 individual tiles for 6 different sides. And it will actually not be 6 different sides but 7 different sides because I want to also store the fully empty dice. So let's just start with that. Let's pretend that this is number 0. This will be fully empty dice. And in this case, all those tiles will be empty. So let's just set it as 0. So 0, 0, 0, 0, 0, 0, and finally 0, 0, and 0. I will copy this entry 6 more times. So this will be number 1. In this case, the middle one will be set to 1. For number 2, those corner ones will be set to number 1, and so on and so on. So number 3 will look like something like this. Number 4 will have those corners set to 1. For 5, it will be corners as well as the middle piece. And finally for 6, it will be left column and right column set to 1s. I don't need this last comma, but I think that I need to put one more semicolon after everything. So now I can use this array as a lookup table to find out if I want to draw the circle piece or the empty piece. So I'll just copy this array in the clipboard, and inside our draw dice function, I want to add the if statement. So I will say that if the dice tile lookup of the dice number and the second index should be I equals 1. In this case, I will draw the dot. If that's not the case, meaning that if the dice tile lookup equals 0, I will draw the empty image, and that's named dice empty. So just copy this name into drawing the empty image. I think that I'm missing a bracket in here. And inside our main loop, let's just call this draw dice function with some value. So for example 5, and let's actually draw 2 dices. So the right one will be on the x position 10, and as for the value, let's for example use number 6. Let's restart the simulation, and hopefully we will see dices showing numbers 5 and 6. And that's not the case because there is something wrong with our array, and yeah, we are missing some commas in here on the first line. So let's just edit those back and restart it one more time. And now we can see those dices correctly displayed. Now before we move on, let's also draw some text to make it more interesting. And I already have this set font and drawstring function, so I'll just copy this one into our setup function, uncomment those, and instead of drawing hello world, let's say dice game on the position x being 0 and y being 1. And I will actually add a few more empty characters to fill the entire line because later on I will draw different messages, and this is the simplest way how to update the entire line. So again, one more restart, and now it looks more like a game because it says game up here, of course. Let's continue with the game by drawing random dices all the time. And for that, let's create 2 more variables being the type of byte, one being the dice left, and let's just set it to 0, and the second one being the dice right. Now inside our loop, what I will do is I'll just set those to random values. So I'll set the dice left to be random, and I can specify the range of the random value, and I want it to go from 1 up to 6 for both the dice left and dice right. And then I will use those values for drawing the dices. I will remove the delay to see how fast we can update the dices and restart the simulation. And it's not very fast, it's actually quite slow. And the main reason for this one is that we are using the software I2C connection, but we have to use that one because of the way how the OLED display is connected to the ATtiny85 chip on the TinyCade arcade machine. But I think that we can make it faster by not drawing all those 9 pieces all the time, because sometimes it happens that the previous number also has a dot or maybe empty piece, and in that case we don't have to update the tile. So what I will do is I will create 2 more variables and just call those dice left previous and dice right previous, and inside our draw dice function I will add 4th parameter, and this one being dice number previous. And so I want to update the dice tile only if it was different from the previous dice. So inside our if statement, I want to say that if the dice tile lookup equals 1, but at the same time, so and at the same time, the dice tile lookup of the previous number, so dice number previous, is actually not 1, so if it's different, so if it's not 1, only in this case I want to draw a new tile, and I will use the very similar if statement in here, so I will say else if the dice tile lookup of this number equals 0, but at the same time if the previous number was not 0, only in this case I will update it with the empty tile. So inside our loop function I need to include this parameter, so it will be dice left previous and dice right previous, and after we draw this I want to update those values, so the dice left previous will equal to dice left and the dice right previous should equal to dice right. So let's restart the simulation and see if there is any difference in speed. And there is quite a lot of difference actually. We are now updating the dices very fast, much faster than we need to. Now I want to include some kind of delay between changing the values, but if I include the delay function, for example set to 500 milliseconds, being half of the second, during this time I will not be able to read the state of the button, so I will not be able to get the button click. So instead of using the delay function, I will just store the time from the start of the simulation, from the start of the sketch, and then compare it to the previous time when I was storing the time. And if this value is bigger than 500, only in this case I will set the new values. And for that I will be using the Arduino function called millis that will return the number of milliseconds since the program started. Now the important part is that the type of the variable should be unsigned long. So I'll copy unsigned long into our sketch and let's just call this elapsed time in millisecond. And we need one more variable that will store the previous value. So inside our main loop we will get the elapsed time in milliseconds by calling the millis function, and then create the if statement saying that if the millis minus the previous value is bigger than some value, for example 500 milliseconds, only now we will update the dices with new values. And of course once everything is done, we want to set the previous value to the current value. So if I restart the simulation now, I should see the very same output, but now I'm not stopping the sketch using the delay function, but I can do whatever I want outside this if statement. And let's get the state of the button so we can press the button when the dices are the same. For that we need to first set the pin mode for the button inside the setup function. And if I zoom out, I can see that the first button is connected to pin 0, so let's use this one and say pin mode of the pin 0 should be set to input. And then inside the loop function, I can get the state of the button by calling the digital read function. So I can say that if the digital read function of the pin 0 equals high, that means that the button is pressed and we should do something. And before we do something, let's add one more variable, and that variable will store the status of the game. So let's just call this game status, set it to 0, and let's decide on some values. For example, let's say that if the game status is 0, we are waiting for the game to start. If it's 1, the game is running, and finally if it's 2, the game has ended. And so based on this game status, we will do different things when the button is being pressed. When the game status is a 0, we are not doing anything, so pressing the button will start the game, and when the game status is 1, pressing the button will end the game, either ending up as a winner or not a winner. Which means that we will need more if statements in here. So let's just say if the game status is 0, again we are waiting for the game to start, which means that we should start the game. And when we started the game, let's just draw a different label, different message. For example, saying that pressing the button will stop the game. but since we don't have enough characters, I will just say that press button equals stop, and then we'll start the game by setting the game status to 1. Another option is if the game status is 1, in this case the game is running, and so after pressing the button, we need to find out if there is a winner or not. And we will do this simply by comparing if the left dice equals right dice. In that case, we have a winner, so we will show a message saying winner. If the left dice does not equal the right dice, in this case, there is no winner, and so we will say, sorry, not a winner. In either cases, we will set the game status to 2, which means that the game has ended. And that's also the last possibility, so else if the game status equals 2, the game has ended, meaning that we want to jump back to the beginning, meaning that we need to set everything to the default values. So we will set both the dice left and the dice right to 0. Then we will draw those dices and set also the previous values to the current values. We will draw the string saying dice game. That's actually the same string being used in the setup function. And finally we will set the game status to 0, meaning that the game hasn't started yet and it's all the way in the beginning. Now to prevent jumping between those individual states too quickly, I will add a small delay of, for example, 50 milliseconds, and there is only one small thing missing, and that's this one. We only want to change the dice's values when the game is running, meaning when the game status is 1. So I'll add one more if statement saying if the game status is 1, only in this case we want to change those values. And I think that this might be all that's needed, so let's restart the simulation and see if we can actually play the game. Let me actually zoom in so I can see more of the display, but also at the same time the left button. You can see that this is the start of the game. We show the message dice game, but those dices are empty. So if I press the left button, now it should be playing. And I will just wait until both of those dices will be the same. And I wasn't able to catch it, so sorry, not a winner. Let's press it again to go to the beginning, and let's try it one more time. And after a few tries, I was able to win this game. So I think that we can try it on the TinyCate and on the breadboard version, which means that we need to upload the sketch to the ATtiny85 chip. And since the chip doesn't have the USB connection, we need some kind of programmer. In my last video I was using this programmer, which is called USBtinyISP, but this time I will simply use Arduino UNO to program the ATtiny85 chip. And it's quite simple, but we need to do a few things before hitting the upload button. The first thing is to tell the Arduino UNO to act as the ISP programmer. First we need to open the Arduino IDE and select our Arduino UNO board, and then go to File, Examples, and select the Arduino ISP and open the Arduino ISP sketch. And this is the sketch for turning the Arduino UNO into the ISP programmer, so I need to hit the upload button to upload the sketch to the Arduino UNO. Now uploading the sketch to the Arduino is done in a way that when you open the serial communication, the Arduino will reset and the bootloader will look for the new sketch, but at this point we don't really want to upload any new sketch to this board, so we don't want to reset the board when you start the serial communication, and that could be done by connecting a capacitor between pins ground and the reset. If you try to upload the sketch now, it will not do anything, and that's exactly what we want. You can see there is an upload error because the Arduino never resets. So now it's time to connect the ATtiny85 chip to the Arduino board. And if you search on Google for images, they are pretty much all correct. It's just sometimes they are showing the pin numbers going from 1 to 8, and other times they are showing the pin names being PB012 and so on. In any case, we need to connect the VCC to 5 volts and then ground to ground, and then 4 more pins being the pins 7, 6, 5 and 1 to pins 13, 12, 11 and 10 on the Arduino UNO. As you can see, I'm using this very cheap but very useful prototyping shield, and I've even printed this overlay, so hopefully the connection is clear. This is the VCC going to 5 volts and this is the ground going to ground. The advantage of this prototyping shield is that you have multiple pins for ground and 5 volts, and then we have pins connected to pins 10, 11, 12 and 13. You can see that I've also placed the capacitor between the pins ground and reset. So when we have everything prepared like that, we can jump back to the Arduino IDE. And here we need to add the support for the ATtiny85 chip, and we do that by going to File, Preferences, then opening the Additional Boards Manager URLs by clicking this button and adding one more entry, which will be this one. I will put the link down in the description. Click the OK button and close this dialog, and then go to Boards and type in ATtiny85 and install this ATtiny by David A. Mellis. Once you have this installed, you should be able to go to Tools, Board and select the ATtiny85 chip. And if I open the menu again, I should go to processor and make sure that the ATtiny85 is selected and select the right clock speed. And you can choose whatever you want, you can choose internal or external, but I think it makes more sense to select the internal one, and I will try to go with the fastest one being the 16 MHz. Now the important thing is that by changing the clock speed, we are actually not doing anything to the chip, we are just checking the checkbox in the UI. And so the way the chip works is that the speed is set inside the chip using something called fuses, but there is no set fuses menu option in here. Unlike for example in the AVR application where I can read and write the fuses. So if I click read, it will read me all the fuses and then I can set those, even when it's of course a little bit cryptic. By the way, if you want to use the Arduino UNO as ISP using the AVR, you should select the ATmel AVR-ESP. It took me a long time to realize this. Anyway, back to our fuses in the Arduino IDE. So there is this menu option called Burn Bootloader, and it might be a little bit confusing because it's not only burning the bootloader, but also setting the fuses. And actually for the ATtiny85 chip, it's only setting the fuses, it's not actually burning any bootloader. So this is something that we need to start with, and before doing so, we need to make sure that the programmer is set to Arduino as ISP, and after that click the Burn Bootloader. So it will show you the message burning bootloader, and hopefully it will also show you done burning bootloader, which means that the fuses were set. And so after doing all of those steps, we can finally upload our sketch. I will copy and paste the code from Walkway. Now if you have never used the U8G2 library, you have to go to libraries and then search for U8G2 and install the U8G2 library, which also includes the U8x8 library. And then we can finally upload the sketch by going to Sketch, Upload using Programmer. And after a little bit of waiting, we can see that our sketch was successfully uploaded to the ATtiny85 chip, taking 72% of the flash memory and 73% of the RAM memory, so we should be still safe. At this point we need to remove the chip from the prototyping board, put it on the separate breadboard and connect it to the OLED display and the button and of course the 5V power supply. And the connection is very same as inside the Walkway sketch, but we are only using one button, so this one is not being used, not this one, and not those two resistors, and I don't have any buzzer, so I can delete this one as well, which leaves us with a very simple connection. The OLED display is connected to pin PB3 and PB4, and the button is connected to the pin PB0. All the other connections are just grounds and 5 volts. Again, this is how it looks like on the breadboard, and if I connect the power supply, I should see the very same game which I can play. And since I'm using pretty much the same connections as in the TinyCate, I should be able to just remove the chip from the breadboard and put it inside the TinyCate and be able to run this game there as well, which seems to be the case. By the way, with just half second delay, this game is quite challenging. And somehow it gets harder the longer you play it. And so that's it, that's how you created the simplest possible game for the ATtiny85 chip. If you have any questions or comments, or if you have already created some game, or if you want to see more videos like this, please let me know in the comment section. Thank you very much for watching and I hope to see you soon. Thanks and bye.